All right, so we've looked at what insurance would look like if it were risk prefers who were insuring risk averse consumers. And while in principle that can work, it seems pretty impractical that you'd be able to find enough risk prefers to actually make that function well. And so what I want to do is to look at a more realistic version of what an insurance market might look like. And this is closer to the reality that we typically observe. And in this case, what we have are multiple risk-averse consumers who insure one another. And as long as they don't all face the identical risks, this can work. Okay, if what you have is all the residents of New Orleans insuring one another against flood, and they all happen to be flooded at the same time, then there's not much of this isn't going to work at all. But if you have people from New Orleans and from other parts of the country all together insuring against flood, well, some people will experience floods while others don't. And that allows the insurance to be insurance that is what we call mutual insurance, where people are insuring one another. Let's see how this would work. So suppose we had two risk-averse consumers. Okay. And for each of them, income looks just like the risk-averse consumer that we talked about before. Their income could be $50 or $100, and the probabilities are 0.2 and 0.8. And we know that that means that the expected income for each of them will be $90, and the expected utility will be 9.41. Okay. So instead of having each of these consumers on their own, facing this uncertainty, what they could do is to pool their incomes and split the total evenly. So we will simply stick our incomes together and then split the result in half. Okay, and so let's think about what this might look like. And so consumer 1 and consumer 2 each have incomes of either $50 or $100, 50 or 100. If they each have 50, then the total will be 100. 100 divided by 2 is 50. They each get 50. In this case, 150 divided by 2, they each have an income of 75. Here, 150 over 2 is 75. And 100 plus 100, 200 over 2, they each have an income of 100. Okay. What are the probabilities? Well, let's replicate this table with probabilities in it. So that's consumer 1 and consumer 2, 50, 100, 50, 100. So the probability that the first consumer will have an income of 50 and the second consumer will have an income of 50, assuming they face independent risks, that probability is going to be 0.2 times 0.2, which is 0.04. The probability consumer 1 has an income of 100 and consumer 2 an income of 50 is going to be 0.2 times 0.8, 0.16. This will be 0.16. And the probability that they both have incomes of 100 is 0.64. So let's look at the overall income. Let's just call this x1 plus x2 over 2. So this is the income per person. It looks like that income per person is either going to be 50, 75, or 100. So it's going to be 50, 75, or 100. The probability associated with each of those is 0.04. This can happen in two ways, the $75 outcome, so that's 0.32, and this is 0.64. And now we can find the expected income for each consumer. So this is going to be x1 plus x2 divided by 2 times the probability of each of those values. So I'm just using a dot to represent this whole thing because for two reasons. One, this is a standard thing that economists and statisticians like to do, is to use a dot to represent a whole thing like that, because we're all lazy and don't want to have to write the whole thing out. All right, so 0.04 times 50 is 2. 32% of 75 is 24. And 64% of 100 is 64. And so that comes out to 24 plus 64 is 88 plus 2, 90 is the expected income per person. So the expected income is the same. What about the expected utility? So we want the utility of x1 plus x2 over 2. So square root of 50 is 7.07. Square root of 75 is 8.66, and square root of 100 is 10. And we're going to take the utility times the probability. So that's 7.07 times 0.04, that's 0.28. 8.66 times 0.32 is 2.77. And 10 times 0.64 is 6.4. That comes out to 9.45. And what we establish is that when these two consumers, both of whom are risk averse, when they just pool their incomes and split the results, they have an expected utility that's greater than what they get if they go it alone. And so what this says is that this sort of mutual insurance, where people who have similar risk attitudes insure one another, this is a way to spread risk over a number of people, make everyone a little bit better off, without having to rely on anybody who is a risk preferrer to write an insurance policy. And as you add more and more, this is just with two consumers, the utility goes up a bit. If you have hundreds of consumers, each of whom faces independent risks, who mutually insure in this way, then they're all going to be much better off than they would be if they were on their own. And so that's what mutual insurance looks like. And I'm going to stop there.